In this video, we are going to review the characteristics of exponential functions. We're going to start with domain, then we're going to go over range, Y-intercept, and asymptotes. Okay, so we are starting with this line right here, this exponential function. Well, we know that this is a decay function because it's going from very high values to very low values. We also know that this line keeps going in every direction, so it's like we have arrows right here. Okay, so I'm going to start with domain, and the definition of domain is all possible x values. All the x values that this line will touch. So I'm going to start from the left side. How far to the left is this line going to go? So I notice that this line is going up, but as it's going up, it's also moving towards the left. And since here we have an arrow, that means that this keeps going forever. I know that it'll start going to the left slowly, but it'll never stop going to the left. So I know that it's going to get all the way to negative infinity. Now this is going to go from negative infinity to what in this direction? Well, here is probably a little bit easier to see that my arrow points directly to the right. What does that mean? This line is going to keep going to the right forever and ever and ever. And we say that that's going to get all the way to positive infinity. So we're saying the x values are going to be touched from negative infinity to positive infinity. And how do we call that? All real numbers. And as far as that, this will be the case for every single exponential function, regardless if it's decay or growth. Now we're going to focus on range. So what is range? Range is very similar to domain, but in domain, we're looking at the x values. In range, we're going to focus on the y values. So now I'm going up and down, and I'm trying to see how far down will this line get and how far up did this line get. So here we're going to see an interesting thing with the exponential functions. As I am going in this direction, I know that this line is going here, and when it reaches a point, it's almost like it's going to move straightly to the right. So what we are saying is that as far as the y values, this line will get really close to 0, but will never touch it. Now, how high did it get? According to this arrow right here, it's going to go all the way up. So the line, my function, will get really close to 0 but never touches 0. And then from 0 is going to go all the way to positive infinity. How can I say that? How can I say that the y values that this line can touch is going to be really close to 0 but not 0, because it's never going to touch it, all the way to infinity? And we just say that the range can be any y value greater but not equal, so we're not going to put our line under, to 0. Now we're going to focus on the y-intercept, which after domain and range, the y-intercept is actually very simple. What is the y-intercept? Wherever my function touches the y-axis, which in this case is as simple as saying it touches right here. Now, what is the y-intercept? The y-intercept is 0, 3. Or we can just say 3, because we know that in every y-intercept, the x value is 0. So all that we need to know is what is the y value that is going to be touched by this. The next characteristic is the asymptote. This is the new characteristic that we're going to see, because neither linear or quadratics have had this before. So first of all, what is an asymptote? An asymptote is an invisible line. It's an invisible line that it represents the y value that my function gets close to but never touches. It gets very, 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 very close, but will never cross it or touch it. Now in this case, let me give you an idea of what I'm talking about. It's almost like this line has a limitation. It's almost like there is an invisible line, even magnetic force if you want to think about it that way, that is not allowing this line to touch here. This is what we're talking about. This will be my asymptote, because my line will be able to get really close to this line but never touch it or cross it. Now here's where we have to pay attention on how we write it. This is a horizontal line, so it'll always be y equals. Now, which is the y value that is approaching? If I can just look at it, what is the y value that this line is touching? Is the y value of 0. So I just say y equals 0. So these are the characteristics that we look in exponentials: domain, range, Y-intercept, and asymptote. So let's look at a different example. So here we have a different one. It's still a decay, okay? So we're going to start with domain. As we said before, domain represents all the possible x values that this line will touch. So don't forget that at the end, there are arrows symbolizing that this line keeps going in either direction. So, how far the x-axis goes from left to right. How far to the left is this line going to get? According to this arrow that is pointing out, I know that it's going up, but at the same time that it's going up, it's moving to the left slowly. Is it ever going to stop moving to the left? Never. That's what we say, that this line is going to go all the way to negative infinity, all the way there. Okay? Now, how far to the right is this line going to go? To the right, well, the line is pointing that it's going to go all the way to infinity. Okay? So it's going to go all the way to infinity. So from negative infinity to positive infinity. How can we say that? Well, from negative infinity to positive infinity will be pretty much all real numbers. And this is what I was saying before, that in the case of exponentials, the domain will always be all real numbers. But this is how we can prove it. Now we're going to do range. And range is very similar. But now, instead of focusing on the x-axis, we're going to focus on the y-axis, up and down. So the first thing that we need to know is, how low would this line get? And here's where I noticed something very interesting, because my line is like it's getting close to this number, but never touches it. That's as low as it gets. Because now, how high would it go? All the way up, that way, to infinity. So this is what I'm saying. I can see my line getting lower and lower and lower, but then here, kind of like staggers. It's almost like it cannot cross or touch this number. That's why we're going to stop it here. We're saying it's getting here, but it's not touching it. Now, what number is that? This is a negative 2. So what does that mean? Then my range is going to be any y value greater, but not equal, to negative 2. The next characteristic will be Y-intercept, and this one will be a lot easier, because the only thing that I'm looking for is what? Where is my line touching the y-axis, which in this case will be right here. So what is my y-intercept? Is 0, 0, or I can just say 0, because I know that the x value for any y-intercept is always 0. The last one that we look at is the asymptote. What is the asymptote? That imaginary line that my exponential will always get close to, but never touch or cross. In this case, I can see that my asymptote will be here. Why am I saying that? Because I notice how this line, this function, is getting really close to here, but then as soon as it's getting close to it, it's almost like it's diverting it. It's trying to, it cannot touch it, so it keeps going, starts moving, so it won't be able to touch it. So how can I say that? Well, this is a horizontal line, and horizontal lines are always y equals, which is the y value that this line is at. It's at -2, so it'll be y equals -2. We're going to do one last example. So here we have a very different exponential function. Why? Because in this case, we have an exponential growth, okay? Now this one is closer, so let's see what we can do with it. We're going to start like always with domain. Don't forget the domain is my x values. So what does that mean? I must not forget that my line has arrows on both sides. And I need to know by domain how far to the left and how far to the right is going to go. Well, left, I can see that this is going to go forever to what we call -infinity. And it's going to keep going in this direction to the right. Now here we have an arrow pointing up. But as it's pointing up, I know that it's also pointing, or it will move slowly into the right, but it'll never stop moving to the right. That's why we say that it can go all the way to infinity. And when I have something going from -infinity to +infinity, we said that this is all real numbers. Okay, so now we're going to look at range. What do I know about range? That is basically this idea about domain, but instead of the x, now I'm looking up and down because I'm looking at the y. So I'm looking at the y, and I want to know how low can my line go. And then I notice here, this number right here. I notice that my line is getting really close to this, but as it's getting close to this y value, it starts like turning, like it doesn't want to touch it. So that tells me that it doesn't want to touch this number, but it'll touch anything from here up. How can I say that then? Then my range will be any y value greater but not equal to what number is this? -5. As simple as that. Now the next one is probably the easiest characteristic. We are talking about the Y-intercept, and later you're going to see why we pay so much attention to the Y-intercept. The Y-intercept is just where my line touches the y-axis, which in this case, it happens right here. What value is that? Well, that's the 0, -1, or I can just say -1. At last, we have the asymptote. And what is an asymptote? It is an imaginary line that my function will not touch. And here I find that this is going to be it. Why? Because as my line is getting close to this line, to this y value, it starts turning because it doesn't want to cross it or touch it. It's avoiding it. So this right here will be my asymptote. Now my asymptote, it is a vertical line. That's why I know the vertical lines are always y equals. And which is the y value that it touches? -5. That's why it will be -5. Y equals -5. I hope this helps you to find the characteristics of any exponential function.